The next service is the plate classification service. So just like other services, the plate classification service has configuration for production and development. Both are same with the exception of the database URI and the broker URI. Some important aspects of this configuration file are the location of the deep neural network weights for classification of images, some parameters to load the network with, the height and image the neural network expects, the channels the neural network expects, and this is kind of a threshold where we say that the network must be at least 90% confident about the detected image before we stop processing the next detection. Once you check out the code, you will not find any of these models because I have not published these. I'm still working on tuning these models, so in a matter of few days I will be publishing the images, the source files that you can use to train your own models, complement them with wherever you are so that the system performs on your local number plates, as well as these models if you would just like to try things out. So coming to the code, just like the other services, we have the main code which just starts loops, and we handle the signals to gracefully exit in case there is an interrupt or any other kind of signal received from the OS. The plate classifier similarly has a consumer and a publisher. The consumer reads the incoming messages from the detector and publishes it to another exchange, which is picked up by the next service, OCR, which we're going to talk about in a few minutes. The loop for error function calls start on the consumer and publisher threads. So if we look at this function, which is new image queue, this is the one which is executed every time there is a message published on the associated exchange and the queue receives that. So we load the document and we load the image into a NumPy array. We do some pre-processing and we simply slice up the image into the required size which we're going to be feeding into the network. This happens to be the width and height specified over here in the YAML file. So once we have these slices, so we slices as many number of times as the number of detections that we made in the plate detection phase. So if 10 plates were detected, we will loop over 10 times, each time extracting an area of the image that conforms to the size we require to do a plate classification. In other words, a 300 by 300 slice of the image around the area of detection, and we will then try to save it for the sake of referring back to it later on. We'll save the detected plate with this naming strategy where the ID is generated according to the detection array number. We just save the file and then we try to convert it into the correct RGB format to be fed into the classifier. The classifier itself just executes a neural network and returns us with the plate type and score. So we just take back the score and the type and we append it to the classifications of the image of the message we had earlier read from the queue. Eventually, after we're done looping and we have classified all of the detected plates with the type and the confidence, we just save the data to the database and we publish the message back to RabbitMQ to be picked up on the next stage. The invocation of the neural network is carried out over here in the classify plate function, where we expand the numpy array to convert it into an array, and then we pass it to the neural network for processing. This code still needs some optimization, which I will be doing in the future, and publish updates for this. There's still a lot of speed that can be gained, such as if this piece of code, it can be revised to take an array of images instead of taking it one by one and return the results as a collective. But that is to come in the future. So this is the third stage of the open LPR, which is after detection. So we have images coming into FTP, which is distributed over detection service, and the results of the detection is distributed over to the classification service.